Hello, today we're going to start with our next lesson using formulas. A formula is an equation that expresses the relationship between certain quantities. A formula or equation that involves more than one variable is called a literal equation. So, involves more than one variable. Solving for a specific variable. Now, what we're getting to here is that everything we've learned applies to numbers. All the rules of equalities apply to numbers, and a variable is just a number. Since it's just a number, we can manipulate it just like anything else, and we can solve for it. So here we have 5a minus 2b equals 15. Solve for a. First thing they do is they have us add 2b to both sides. By adding 2b, we're canceling out this b over here on the left and moving it to the right. So cancel, cancel. 5a drops down, 15 plus 2b. So from here, we now are going to divide everything by 5. Dividing both sides by 5 here puts grouping symbols around our numerator. The 5's cancel, so we're left with a equals 15 plus 2b divided by 5. Now, simplifying, as long as the plus or minus sign is on the top. As long as those plus or minus signs are on the top, like right here, we have a plus sign, this will split into two different terms. So we have 15 over 5 plus 2b over 5. From here we can simplify. 15 divided by 5 gives us 3. And 2b divided by 5, we can write this as 2/5 b. It says, think about it, how do you solve an equation for a specific variable? Well, it's easy. It's how you solve anything. You isolate it on one side of the equation. Think about it. Describe how you would solve for b instead of a. How would your answer change? Well, if we were to solve for b instead of a, instead of adding 2b, I would be subtracting. So if we put these into steps, step 1, 2, 3, 4, 5, and 6. My new step 2 would be to minus 5a from both sides. After we subtract 5a from both sides, my new step 4 would be to divide by negative 2. So the addition subtraction step removes the a, and we're left with a negative 2b on this side. And then if we divide by negative 2, that would leave us with the b. How would the answer change? Well, we can. So what we're going to have at the end of this step, we will have negative 2b equals 15 minus 5a, and then we get b equals 15 minus 5a over negative 2. We can just leave it as a fraction. There's not much cleaning up we could do right here with that. Example 2. We're going to solve for p. It has us add 7r to each side. We have a negative 7r here, so by adding 7r, we are going to move it from the left to the right. 7r cancels here, cancels here. 4p drops down, and we are left with pq plus 16 plus 7r. From here, it has us subtract pq from both sides. Now, this p is attached to the q. What we are doing is we're moving everything that has this p term to the left. So we're going to minus pq minus pq. Our like terms over here cancel. And now I have 4p minus pq equals 16 plus 7r. Now this next step, this is the factoring. We are factoring out p. It's the opposite of the distribution step. We see that there's a p here and a p here. So if you were to do distribution, p times 4 is 4p. P times negative q is negative pq. From here, we're going to divide each side by the quantity of 4 minus q. These two 4 minus q's cancel, leaving p, and we're left with this fraction 16 plus 7r divided by 4 minus q. What makes this one hard is that we start using two terms as a number, so make sure you're putting your parentheses in here to not get overwhelmed. All right, we're at our first check. Please take a moment to try and solve this. Copy it down. You may pause if you want. All right, we have to solve for v. What we see is we have a v on the left and a v over here on the right. So we have to first get everything on a leveled playing field. We got to get rid of this t underneath by multiplying both sides by t. Cancel, cancel. I now have 2tv equals w plus v. Next up, I'm going to subtract v from both sides. That's going to get both my v's over here. So I'm going to have 2tv minus v equals, cancel, w. Let's restart it up here. Now what I'm going to do is I'm going to factor. I see that there's a v here and a v here. So I'm going to write that v out front. 2tv divide out the v is 2t. Negative v divided by v becomes a 1. So minus 1 equals w. Final step, we're going to have to divide both sides by this quantity, 2t minus 1. Cancel, cancel. We're left with v equals w over 2t minus 1. And talk about it. Would the solution be the same if the variable p were isolated on the right side of the equation instead of the left? Explain your reasoning. So what it's saying here is, would we get a different answer if we moved everything? No. If we moved everything over here, we'd still get the same solution. This is what P is equal to in terms of R and Q. It's not going to change. We're just moving them from one side to the other. Example 3. Solve literal equations for a given variable. The area of a trapezoid, A equals H times the quantity of A plus B. H times quantity B1 plus B2 over 2. This here, a trapezoid, just for reference. So that's height, base 1 and base 2. What this really is this is an average here. So this is A equals the average of our base. So B1 plus B2 over 2 times height. It's base times height, but since there are two bases, they're being averaged. When we write it like this, I always fear we're losing that distinction that as a quadrilateral, it is base times height. Its base is just an average of the two. H is the height, and B1 represents the length of one base, and B2 is the base of the other. We are going to solve this formula for H. All right. So first off, has us multiply both sides by 2. By multiplying both sides by 2, that's going to cancel out our 2 at the bottom. Simplify. All right, 2a equals h times quantity b1 plus b2. So we're going to divide both sides by the quantity b1 plus b2. Remember, the parentheses let us use this as a number. So cancels out over there, leaving h, and we have 2a over b1 plus b2. So if we know the area and we know the two different bases, we set up this formula and it'll tell us the height. Part B, find the height of a trapezoid with an area of 70 square feet and bases that are 22 and 18. All right, so we're taking our formula, and what we have is parts for fill in the formula. We have A, our area. We have B1. And we have our B2. I always like to highlight, makes it easier to understand where numbers are going. So from here, we have to simplify. 2 times 70 is 140. 22 and 18 makes 40. We are going to simplify this. First thing we can simplify is make this 14 over 4 by getting rid of those final zeros. Cut it. We can cut it in half. They're both even to get 7 over 2. So we have 7 over 2 feet, or we could just say 7 cut in half is approximately 3.5. So the height of the trapezoid is 3.5 feet. Divided by a quantity. Do not forget to divide each side by the entire quantity b1 plus b2. Yep. Think about it. How would the height of the trapezoid change if the area were doubled and all other measures were the same? Well, if we double the area, we're just multiplying this part by 2. Since area is up here, if we were to double it, that 2 just becomes a scalar out here. So essentially what we're saying is we'd have a 2a over our b1 plus b2. By doubling the area, this is the same as saying 2 times 2 times a over b1 plus b2. And by orders of operation, what I can simply do is first solve this, and then it gets multiplied by 2. So doubling the area of the trapezoid will double the height value we have here. All right, next check. Pause it, take a break, try it out, come back, let's do this. A mason jar company wants to increase the volume of its cylindrical jars by 6 cubic inches. The company's designer wants a formula that states the height h of a jar, given its volume v and radius r. All right, very straightforward. Volume v, radius r. The equation we get to deal with is v equals pi r squared times h. All right. What formula will we use to find h? Well, this is all multiplied right here. This is the same as saying pi times r times r times h. So we can just divide out pi r. So we are going to have pi r squared h divided by pi r squared. Cancel, cancel. So we should have the volume is divided by pi r squared. Volume divided by pi r squared. Here we go. B, if the radius of the jar is 1.5, and the original volume is 30 cubic inches, then what height should the company make its new jar to increase the volume by 6 cubic inches? All right, so it wants to go from 30 to 6. Sorry, from 30 to 36. So we have our volume is 36. The radius is still 1.5. We're going to plug it into the formula. H equals volume over pi r squared. From here, H equals 36 over pi 1.5 quantity squared. Let's grab a calculator. 36 divided by the quantity pi times 1.5 squared. And we get approximately 5.1. So we got 5.092958179. So we're going to say approximately 5.1. is our new height. When an equation has more than one variable, it can be helpful to highlight the variable for which you are solving on a piece of paper. Highlighting it shows you which one you are trying to isolate. Example 4. The total amount of money Kishi spends on pizza for a party is T equals 13.49C plus 15.49P. T represents the total amount of money spent. C represents the number of cheese pizzas. P is the number of pepperonis. Got it. So we have the price of a cheese pizza and the price of a pepperoni pizza with variables telling us the number of pizzas. Part A. If the total is 85, describe the constraints. All right. Well, we can only buy whole pizzas. The maximum number of cheese pizza Kishu can buy is 6 because she can buy 6 cheese pizza, no pepperoni pizzas without exceeding $85. True. The maximum number of pepperoni pizzas Kishu can buy is